Okay, this section is about variation, direct variation, inverse variation. So for this variation, there are two mathematical models. So one is direct variation, the second one is inverse variation. Okay, whenever there's a sentence like this, y varies directly as x, or y is directly proportional to x, then we can write an equation as y varies, so write down y equals k times x, k multiplied by x. This x is the one that follows this. So directly then multiply k by x, and we call this k constant of variation. And if on the other side, the inverse variation is this. Inverse variation is y varies inversely as x. This time, instead of directly, there is a word inversely. And also y is inversely proportional to x. Then this is inverse variation, and the equation is y equals k divided by x. K divided, not multiply. For direct variation, you multiply the k, the constant variation k, by what comes next. But for inverse variation, don't multiply, divide the k by x. So for direct variation and inverse variation, we have to write an equation, mathematical model that relates to this. So y equals k times x if there is a word direct, directly as x or directly proportional to x. The inverse, we divide k by x if there is a word inversely. And then for each equation, we have to find the constant of variation k. We have to find the k value. So in order to find k, we gotta know the values of x and y. So always the values of x and y are given so that we can find k, the constant of variation. So let's check exercise 1, example 1. The total revenue is directly proportional. Here's a directly. So this is a direct variation. So directly proportional to the number of tickets sold. So y, so r. So we can write it as this. R is equal to directly proportional, so k times, right? K times proportional to x. So k times x. So this is the equation for this direct variation. And then we need the values of r and x to find this k. This one looks like a k, so r and x. Okay, the next sentence gives you the values of r and x. So there are 10,000 tickets are sold. 10,000 tickets. So x is 10,000. And the total revenue is $142,500. So this is the value of r. So let's substitute these values for r and x. Then r is 142,500 is equal to k times x. X is 10,000. So let's find the k. So divide each side by 10,000. Then k is equal to, do a little calculation. Use the calculator. Well, you don't have to use the calculator. We can move the decimal point to the 1, 2, 3, 4, or 4 to the left. So it will be 14.25. So k is 14.25. So our mathematical model that represents this is what? The revenue is equal to, so replace this 14.25 with the k value, with the variable k, 14.25 x. So this is the equation that represents this direct variation. Okay, let's try example 2. Okay, this example 2, okay, let's write a mathematical model. So the distance as spring is stretched. So here is a spring like this, and if you apply a force, then the spring will stretch. So in this case, this is the spring. So once you apply a force, then it will stretch. It will stretch this much, the distance d. So the distance is directly proportional. Okay, it says the distance a spring is stretched is directly proportional to the force on the spring. So why don't we use distance? Okay, the distance, use the variable d, and then the force, let's use the variable f. So we can write an equation. The distance that a spring is stretched is directly proportional. So k multiplied by, okay, directly then multiply k by the force, this. And then we gotta find the constant of variation k, so that we gotta know the values of distance and the force. And they are given. So 20 pounds is the force, and it stretches the spring 5 inches. 5 inches the distance. So let's plug in these two values. So 5 inches is equal to k times the force, which is 20 pounds. Then from here, k equals 5 over 20. So k equals 1/4. Since we found the k, then let's write the mathematical model. So d is equal to k times f. K times f. So k is 1/4 times f. So this is the equation that represents this direct variation. Okay, and the letter B is how far will a force of 30 pounds? Okay, if 30 pounds is applied, then how far the spring will stretch? So, how far? What is the distance? So since we have the equation d equals 1/4 times f, why don't we plug in 30? So d is equal to 1/4 times, the force is 30, so replace f with 30. Then d is equal to, okay, reduce this one, 2, and this is 15, so 15 over 2. Then 7.5 inches. So if 30 pounds force is applied, then the spring will stretch 7.5 inches. So in order to answer these questions, okay, make sure to write an equation correctly. If this is a direct variation, then multiply the constant variation k. And then if this is the inverse variation, we divide k. And then always substitute the d value and f value so that we can find the k values. So finally, once we get the k value, the constant variation, then we get the mathematical model that represents this. Okay, in this example 3, okay, let's write an equation. So here is inclined area, plane. So when a ball is here, then this ball will roll down like this. So the distance that a ball rolls down on an inclined plane is directly proportional. So the distance d is directly proportional. So this is a direct variation. So write it down. D equals k what? Multiply by k times. Okay, proportional to what? To the square of time. So let's say t is the time. Then square of time is what? T squared, right? T squared. So we can write it as k times t squared. And then we gotta find the constant variation k. So we gotta know the values of t, and they are given. Okay, during the first second, the value of t is now 1. And then from here t equals 1, and then the ball rolls down the plane a distance of 6 feet. So this 6 feet is the value of the distance. So we can replace d with 6 feet equals k times t is 1, so 1 squared. Then from here k equals 6. Now 6 equals k times 1, so k equals 6. So we have the mathematical model that relates to this is d is equal to k equals 6 and t squared. Okay, this is the equation. And from the letter B, okay, how far will the ball roll during the first 2 seconds? So from here, the t value is 2, and we will find the distance d. So using the equation, d equals 6t squared. We know the t value, t equals 2, so d equals 6 times 2 squared. So d equals 6 times 4. Then finally, distance is 24 feet. So after 2 seconds, the ball will run 24 feet. Okay, this example is about inverse variation because the demand for one of the hand tools varies inversely. So this is inverse variation. So let's say the demand is D, and varies inversely as the price of the product. So let's say price is P. So we can write an equation that the demand D is equal to K inverse variation. So inverse variation is what? Divide K, not multiply K. Divide K, so K over the price. So this means if the price gets higher, then the demand will get smaller. So when the price is low, then there will be more people willing to buy. Okay, so from here, let's find the constant of variation K. And then the price is given. So price of a tool, if the price of a tool is $7, so this is P. Then the monthly demand is 50,000. So let's use these two values to find K. So demand is 50,000. K over P is 7.50. So that multiply. So we can do a cross multiply. Then 50,000 times 750 is equal to K. So multiply these two numbers, then there will be 35 and 25, so 375,000. So that is the K value, the constant of variation. So that our equation is, not this one, we get it from where? From this. So the mathematical model is D is equal to 375,000 divided by P. Okay, then let's answer the question. Okay, approximate the monthly demand. Okay, so let's find the D value when the price is dropped to $6. So the price will, then D is equal to 375,000 over P is 6. Then D is, okay, use the calculator, so that is $62,500 tools. So the number of demand is 62,500. Okay, this example is the combination of direct variation and inverse variation. So let's read the question. The demand for a USB drive is directly proportional. Okay, let's say the demand for drive. So this is the number of USB drives. So let's make it X. So X is directly proportional to the amount spent on the advertising. So the amount spent on advertising, let's use variable A. So X equals directly proportional. This is, so we gotta multiply the constant variation by directly proportional to the amount spent on the advertising. So multiply K by A. Okay, and inversely proportional. Here's an inversely proportional. So that we have to divide K inversely proportional to the price of the USB drive. So the price of the USB drive, so let's use P. So we gotta divide this K by P. So dividing K means dividing everything by P. So we have an equation like this, and then we gotta find K. So all the values for all these three variables, A, P, X, are given. So when $40,000 is spent on advertising, so A is 40,000. And the price per unit is $20. The 20 is the price of the unit. Then the monthly demand is 10,000. So X, monthly demand 10,000, so 10,000 units, so X is 10,000. So that, from here, let's plug in all these values. The demand is 10,000. The number of units is 10,000. K times the advertising amount is $40,000 divided by the price of each unit is $20. So from here, we can find K. So we can multiply 20 each side, and 20,000 is equal to K times 40,000. And then divide each side by 40,000. Okay, then K equals, multiply 20,000. Okay, 20,000 is 200,000. Sorry about this one. This is 200,000. So divide each side by 40,000, then K equals, then this will give us K equals 5. Okay. So K value is 5. So our new equation is the demand is 5 times A over P. So this is the mathematical model. So from here, let's answer the question. Okay, when the amount of advertising is increased to 50,000, so 50,000 is the A value. Okay, how much can the price increase? So we want to find P. Price increase. And still remains the monthly demand is 10,000. So D is still 10,000. This is 10,000. So X is 10,000. So from here, X is 10,000. And then 5 times A is the advertising amount, 50,000, divided by P. So let's multiply each side by P. Then 10,000 is equal to 10,000 P, 10,000 P is equal to 5 times 50,000 is 250,000. So divide each side by 10,000. Then P equals $25. So the price of unit is $25. And okay, how much can the price increase? So that means the original amount is, when the advertising is 40,000, then the advertising is increased to 50,000. So when it was 40,000, that was $20. So the answer will be, okay, if we increase the advertising to 50,000, then the price per unit is $25. So we gotta subtract $20 because $20 is the price when the advertisement is $40,000. So this one was for $40,000 on advertising, and this price is the price when the advertising is $50,000. So there will be $5 increase in the USB drive. Okay, then the letter B is, okay, if you increase from $40,000 to $50,000 on advertising, then would you recommend this increased expense in advertising? Okay, then how do we determine on this one? Okay, we gotta find the total revenue. So if the total revenue when we increase it to 50,000 is higher, then yes, we should recommend. So let's find the total revenue. So for advertising amount is 40,000. The unit price is $20, and 10,000. The number of units sold is $10,000. Then the total revenue is the product of these two. So 20 times 10,000 is equal to $20,000. That's the total revenue when the advertisement is 40,000. Okay, how about if the advertisement is 50,000? Then multiply the number of units times the unit price. So that will be $25,000. So these are the total revenues. So once we subtract this one, that is that is, we need to put one more zero, right? One more zero here. One more zeros. So 50,000 unit difference. So that the total revenue when the advertising is 50 is more than the revenue when the advertisement price is 40,000. So yes, we should recommend this increased expense on advertisement. Okay, this example is a joint variation. Okay, joint variation is same as direct variation. Okay, so simple interest earned. So let's say simple interest is, let's use I, variable I. So the simple interest I, okay, earned by a saving account is jointly proportional. Okay, jointly proportional means it's a direct variation, and that there are more variables. So K jointly proportional to the time. So K is multiplied by time. Let's use T. And the principal. The principal is the initial investment amount. Let's use P. So we have an equation like this. And after 1 quarter, okay, 1 quarter is 3 months, and 3 months, okay, we gotta change this month to an year. So 3 months is equivalent to 1 year. So we gotta multiply this. Okay, 1 year is equal to 12 months. So we can cancel out this month. So this is equal to 3 over 12 year, which is 1/4 year. Okay. So whenever we convert a month to an year, we divide this month by 12. Divide the month by 12, so that is the number of years. So, okay, so 3 months is equivalent to what year? 1/4 year. So the T is 1/4 of the year, and the interest for the principal is $120. So 120 is the interest amount, and the principal is $6,000. So let's plug in all these three values. So interest is $120. K multiplied by the time is 1/4 year. Okay, we gotta use year instead of month, and the principal is $6,000. So from here, let's find the K. Okay, so K is equal to 120 times, okay, multiply each side by K. So 120 times K, and divide each side by 6,000. So K equals, okay, 6,000, you can move 1 zeros, and this is 20. So that's gonna be what, 0.08. 0.08. Okay, so we rewrite the equation. Then the equation is I equals 0.08 times TP. So this is the mathematical equation that represents this relation. All right, then let's find the answer. Okay, how much interest? So we gotta find I. How much interest? So what is I? When the principal is 7,500 and the month is 5. So divide this 5 by 12. So that is the number of years. So the interest is 0.08 times, okay, 5 over 12. That is the number of years, and that principal is $7,500. So use a calculator to get the numbers. Then it becomes $250. So this is the interest after 5 months.